In this video, we're going to look at section 4.2, exponential functions. We're going to add on to the family of functions that you've had. Some things to consider here. We have our exponential form, f of x equals b to the x. We have to have b greater than 0, so keep that in mind. And also b cannot be 1. So if you do these on your own, rather than watching through the whole video, that's fine, you can do that, but I want you to compare and contrast, especially these two, and see how they're different when we have a 2 for a base versus 1 over the 2. So basically the inverse there, 1 over b, whatever this is, and how it changes and how it looks. Also, I want you to notice how the shifts work here. This is a horizontal shift. If you had a coefficient on the t, that would be a horizontal stretch or compress. And the same thing here, this is on the output, so that's a stretch of 2. So just some things to keep in mind. So first thing I want you to do is go ahead and plot these points. I can start you off. Just do a table chart, and some good numbers to pick for x's would be -2, -1, 0, 1, 2, 3. That'll give you a good spread of the points to get a nice curve, and you can see how that increases exponentially. I mean, we looked at some of these in Desmos too. On this one, you can actually just pick the same values there. Some will fit better, you'll start to notice, than others in the space that we're given. And basically this will be your kind of sweet spot in here. Okay, so go ahead and fill that out and then meet me back here, or you can work along with me. I'll probably just get the points plotted and then we'll look at it together. Okay, so I've plotted the points for this table here. I just plugged in -2. Remember, this one is actually y equals 2 to the x for that one. So I just am plugging in the values. So I'm putting -2 in there and getting 2 to the -2, which would be 1 over 2 squared. So remember, those exponent laws that you reviewed are really going to come in handy. And so on and so forth. Some things to notice here is the 1/2 is the same as 1 over b, if you notice that. 0, 1 is always going to appear on the graph. And you also will have b lined up with 1. So this is a pattern right in here that you can use to get those key points for the shape of any graph. Now I started off, -2 1/4, but -3 would have been 1/8, and so on and so forth. It's going to approach the x-axis here, and then it starts to, curves up pretty steeply. So if we went to 4, we'd be coming off the graph. So that's it for that side. Now I'm going to pause and get the rest of the points plotted in for the 1/2 to the x. So with this graph, just to remind you, when we have a negative exponent, then we're looking at the reciprocal, right? So for example, if I have that -2, when I plug it in 1/2 to the -2, that's really like 1. Well, we'll do it as 1/2 to the -1 squared, and then that would be 2 over 1, because we're going to use this property when we have a over b to the -1. It really equals b over a, so that's really important. So we take the reciprocal inside there and then square it, so that's where I get the 4. So if I add it in here, if I squeeze in -3, I'm going to get 8 up here. So that might help me just get a better curve. And then I'm going to have a steep part, and then I come down and approach the x-axis, but I never am touching it. This goes to infinity. So you can see here where they almost look just the same, except they are flipped around. And it's really a reflection over the y-axis. And again, if you notice here, I have 1 over b at my -1, right? So 1 over b, 1/2, 1 over 1/2 is 2. I still have 0, 1, which will always appear unless you have a shift. And then you also have b itself when your x value is 1. So hopefully those things help you to do quick sketches when you see these functions. Okay, so in this one where we're going to sketch m of t equals 2 times 1/4 to the t plus 3, we're going to look at it as a quick sketch using our transformation process. So since this is our input area, we have a shift. It's a horizontal shift, right? Horizontal shift, and that's going to be left 3. This is a good review of transformations that you'll see again on the final, and they're just really useful. This 2 is a vertical stretch by 2. By a factor of 2. And the base here is 1/4. So this is our base, b. That goes along with our exponential. So we know if we have b is 1/4, then we know we're going to have certain points on the graph. So I'm just going to write a little note here. Okay, so I just want to point out here, a parent function of an exponential always goes through the points -1, 1 over b, 0, 1, and 1b. So this would be helpful to memorize. So if my b equals 1/4, then I have points. I have -1, and it would be 1 over 1/4, which would be 4. I have 0, 1, and then I have just 1 and b. So these two are pretty easy to remember, and then this -1 just flips it around, right? So that's really helpful information. And when we do logs and know that that's the inverse of exponentials, it'll just be switched around. The a and the b, or x and y just swap. So it's kind of the same idea. So good to practice now. So I'm going to put my parent function on here. I'll put that in the purple. So I have my scale is a little bit scrunched here because I have 2 units per block. You can kind of see maybe a little faded, the ones. So I have -1, and then 4, and then 0, 1, and then 1, and 1/4 be down here. And then if you want to get a couple more points, that's fine. That's up to you. You can, think if you have -2, that would be 16. It's going to be way up here. So it just kind of helps you know where your curve goes. And then this is going to approach the x-axis. Okay. All right. So that's my parent. Then I have some things going on here. I have my vertical stretch of 2. So that means all my y's are going to be multiplied by 2. So I have negative 1, 8. I have 0, 2. And I have 1 and 1/2. Okay. So you don't need to plot the in-between, but if it's helpful to you to write this out, you can kind of do them simultaneously because one's a horizontal shift, one's vertical, so they're not going to affect, one's not going to affect another. But the final one is my horizontal shift left 3. So I'm going to subtract 3 from every x value. So I get negative 4, 8. Negative 3, 2, and negative 2, 1/2. And then just go ahead and plot those on here, and you'll see how it looks. Kind of just pay attention to how that stretch affected things. The shift's pretty easy to tell, but stretches are harder. Okay, so then it's going to come in. So it's vertical stretch, so it's like kind of now kind of coming in a little straighter there. So that is my transformation. Okay, so we're going to finish up this problem. You can do this one as a classwork, or you can work along with me if you want, but I suggest you just kind of pause the video and try it. I'm going to start you off, and then I'll fill in the answer and you can check it. So we have our parent is going to be the 5 to the x, right? And so we would have these points, negative 1, 1/5, and then 0, 1, because anything to the 0 is 1. And then we have just, when we put x in, we have just the base, 5. You could add another one in there if you wanted to, just for good measure. If you wanted to put 2 in there, then that would just be the 5 squared. You could put 225. And then go ahead and plot it. And then look here, you have a horizontal reflection. So all your x's are going to become negative. So that's a reflection over the y-axis there. And then you're going to have your shift. It's a vertical shift. Down 2. So all these are gonna, all the y's will subtract 2. Okay, so I first plotted out the parent just so you can see what happens. Now this curve starts out small and increases because the base is bigger than 1. Where the last one we did, just to point out, it was a base that was between 0 and 1. So it started out high and then goes down. So it almost looks, you know, like a flip. So when we do the flip, the reflect over y-axis, you know, you're going to end up with a graph looking like that. So we can change all our signs on the x's to their opposite. So you can see here what I did with those points. And then for the y's, I have a vertical shift down. So I'm subtracting 2 each time. So that's what my -2 represents there. So then now that I have my points, I can go ahead and plot them. Again, you could just do it right while you're graphing. It's up to you. Okay, so I sketched that right in here. So it's up high, and then it approaches y equals -2. So just to dash that in there. So I have a horizontal asymptote that y equals -2. So I can label that. similar to the rationals where we had asymptotes, but a little easier to figure out. So whenever I have this shift, a vertical shift up or down, my asymptote is going to change. So the last one for this video is going to be a classwork. Sketch P of t equals negative e to the t over 2. So you could kind of rewrite this as 1/2 t if you want, so that you can clearly see that you have something going on there with horizontal stretch or compress. So figure out what that is, and then you have a reflection there as well going on with the vertical. So go ahead and do that all out, and then I'll have the answer here for you. One quick thing to note before you start is E. You probably need to know what that is for approximating, for getting your points on. So if you haven't seen that, E is a number, it's approximately 2.718. It's a number similar to pi. So if you happen to not be familiar with that, you can be able to estimate your values when you go to graph. Okay, so this is what your graph should look like in its final stages. Here's the parent. I put the decimal values for the transformed graph as well, so you could see how that all works out. So let me know if you have any questions when you submit your notes. Just write in the comments, so then I'll get it if you need help with anything. It's part of the purpose of putting notes in and stuff like that. So that's it for this part of 4.2. There'll be 1 or 2 more videos on the rest, and have a great day.